Okay, exercise number 2. Now we are trying to infuse one by one the things that we need to include in our what we call calculation. Now we are talking about phrases just now. So how these phrases can affect to your equations that you need to find, especially the probability of this particular discrete random variable. Now, okay, so exercise 2, the time to recharge the flash is tested in 3 cell phones cameras. Okay, you are talking about 3 cell phones camera. The probability a camera passes the test is 0.8 and the camera perform independently. Means that you're talking independent event. So the first and the second will not be affected by each other. Okay, so if you if the camera passes the test, the probability is 0.8. So what will be the complementary of passes? Let's say we call it as fail. If the camera failed the test, what will be the probability, class? If passes is 0.8,
0.2.
so fail will be 0.2. You're talking about 3 cell phone. Okay, and then we know that each outcome independent. Okay, list the element of the sample space, the corresponding probabilities, and the corresponding values x, where x denotes the number of camera passes the test. Now, everything come to your mind. How should I organize this into a distribution, probability distribution? Okay, now if I'm talking about probability distribution, remember you are talking about this. Can you set up this probability distribution for this particular experiment, class? You know the passes probability is 0.8 and the fail is 0.2, and you know you have 3 cell phones. Can you draw your what we call tree diagram, class?
Yes, okay.
Yes, can you try 1 minute? Yeah, try. You have 3 cell phones. So the first test will be pass or fail. Given the first pass or fail, you can get the second test. Okay, you will have also the pass and fail, and then continue to the third cell phone. Okay, list out the all the sample space from this particular experiment. List out all the no need to just prepare the probability distribution. Okay, first cell, second cell, third cell phone. Okay, pass, fail, pass, fail, pass, fail. It will be a bit taking time because you do it one by one. So you will have PPP, PPF, PFP, PFF, fail, pass, pass, fail, pass, fail, 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 pass, fail, fail, fail. Should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now X denote the number of camera passes the test. So you need to count how many that pass. So X, the number of passes. So the number of passes from 0. Hold on for a second. Hello, Michael. Kak saya ada. Ya, ya, ya. Ya. Apa dia? Oh, yang tu lama tak nak bagi. Oh, okey. Boleh, tak apa. Ambil hitam, ambil sah. Dia boleh. Boleh.
Doctor?
Okey, tak apa. boleh, tak apa. Okey. Okey, baik. Terima kasih. Okey, buat sana. Sorry. My car is at the workshop and then something happened. It should be longer time in the workshop. Okay, now, so you have 0 pass, 1 pass, so you can define from the elements that you have. Yeah? So here 0, here is 1, 1, 2, 1, 2, 2, 3. So your probability will be beginning from 0 until 3. So your X, 0, 1, 2, 3. And this will be your X equal to X. So find the probability of each of these particular distribution. Okay. So if 0, then easy. Multiply 0.2, 0.2, 0.2, you will get 0. What? 0.2, 0.2, 0.2. What will be your probability value? Class?
0.6.
0.08.
6 pula, 008 kot. 2 kali 2 kali 2. 2 kali 2, 4, 4 kali 2, 8. So 0.008. Okay. What if about 1? So 1 you have 1, 2, 3. So for each of 1 of success, pass, you got 2 fail. Means that you will have kecil sikit lah. Saya buat kat bawah. I'll just do it outside the box. So it will be 1 pass means that 0.8 times 0.2 fail times 0.2 fail. How many times? 3 times, right? Plus 0.2 times 0.8 times 0.2 plus 0. Fail, pass. Hello? Salam, ya? Ya, saya. Daripada Hashimah ke, saya tengah ada kelas. Lagi saya telefon semula? Boleh? Okey, terima kasih. Sorry. Okay. So repeat again, fail, pass. So 0.2 times 0.2 times 0.8 pass. So how many, what is the value here? Can someone calculate?
0.069 and 96.
Okay, 0.096, correct. What about 2 pass? So 2 pass, how many? You got 3 also. So you have, let's say I put it here. 2 pass means that 0.8 times 0.8 times 0.2, 3 times, so just time 3 lah. So what is the value here? Why time 3? Because we have 3 times. We pass, here, here, here. So just time 3, right? The same. So what is the value?
0.384.
384. Why so slow? It's correct. Okay, what about 3? So 3, 0.8, multiply 0.8 and multiply by 0.8.
0.512.
Yeah, 0.512. So if you add all these value, you will get 1. So this is what we call the probability distribution for this particular experiment. Now, you need to find the probability at most one camera fail the test. At most. So this is how we solve. Okay. Solution A, find the probability of X reflecting the number of camera passes the test. What is the number? At most 1. So what is the symbol of at most? Less than or equal to. Less than or equal to 1. Right? So what is the value? What are the values involved in this case? Class. Less than or equal to 1. Is 1 included, class?
Yes.
Is 1? Yes, because less than or equal to, right? So you are talking about this 0, 1. So this is reflecting Px equal to 0 plus Px is equal to 1. So you know that the probability is 0.008 plus 0.096. So you will get what here? What is the value here?
0.104.
104, correct. Okay. Now, look at the probability value. Is it too small or is it large? 0.0104.
Small.
Too small. So what is the tendency that this that one at most one camera will fail the test? Oh, sorry, class, here said fail. I'm sorry. So here it said fail. So if we are talking about camera passes the test. If it is X, if passes the test is less than or equal to 1, so what is the reflection of fail the test? Suddenly I realize I made mistake. Sorry, class, this is wrong. So we are talking about the failure. So what is what will be the notation for this particular problem, class?
X less than equal to.
Find the probability at most one camera fail. At most one camera fail. At most. 2 fail, right? If 2 fail, saya pun dah confused lah. I would like to use this probability distribution to reflect the calculation. So if at most one fail, it will be reflecting 2 and 3, right? At most 1. Paling banyak 1 fail. At most 1 fail. So it will be what? Px at most 1 fail. It will be maybe beginning from this particular, I'll just change everything. So if 1 fail means that how many success, class? That would be easier. The way we
pass.
Yes,
2.
2 pass means that less than or equal to 2. Okay. So remember class, look at the question carefully. I made my mistake just now. We are talking about at most one fail means that two will pass. Okay, when you are talking about less than or equal to two means that the probability also for two involved in your calculation. So in this case, okay, so we are talking about px equal to 0 plus px equal to 1 plus px is equal to 2. So you have 0.008 plus 0.096 plus 0.38. So what will be the probability here, class?
Zero point 484.
0.484. Okay, if I took one decimal point, 0.5. So how likely this event will occur, class? If I'm talking, if I'm
Quite
asking
likely.
you, equally likely, this event of what? This event, at most one camera fail, okay, this event is equally likely to occur. Okay, so this is how we interpret this probability. Okay, now number 2, we find the probability at least one camera passes the test. Okay, no wonder. So one. So one but fail, another one is about pass. So px at least one. What would be the symbol? At least would be greater than or equal to 1. So now, greater than or equal to 1, okay, look at the probability distribution. Greater than or equal to 1. Is 1 included? 1 included,
Yes.
right? Yes. So 1 included. So 1 greater than, so 2 and 3. So in this case, px equal to 1 plus px equal to 2 plus px equal to 3. Okay, so take the values of probability values 0.096 plus 0.38 plus 0.512. So what is the value here? What will be the value, class?
0.988.
Any other values?
0.988.
0.988.
0.988. Any other answer?
0.992.
Which one? 0.992. Which one? 6, 6, 8. Seems like this one is correct, because 6 plus 2, 8. 9 plus 8, 17 plus 1, 18. So 5 plus 4, 9. Okay, 988 is correct. 988. Okay, so yes.
I have a question about A lah. The A is at most, right? If we take
Yeah.
at most, if we take success 1 mean already fail 2 ma.
Already failed too.
Because we take 0, 1 and 2, right? If the
Yeah.
But if at most 1 camera fail mean
We have,
2 and 3 only.
so
Greater than 2 and 3.
greater than 2 and 3.
Include 2 and 3.
Define the probability at most one camera fail. At most one camera. So 2 and 3. Never mind. It's okay. I actually get confused because I prepare my answer for success. I'll just check. You can be right. Okay. I will just comment this in our next class next week. Okay. I don't want to get wrong here. So if let's say I'll just keep KIV this first. Okay, later on I'll just correct this if I'm wrong. Okay, you can be right. Okay, so let me check this first. Now I cannot compute anymore because I need to understand the terms when we say at most one camera failed, because we have 3 until 3 what we call success. So what if one camera failed? Okay, never mind, just ignore that. I will just rediscuss this again in the next class afterward. So just focus on the things that we have discussed here. Okay, so thank you for those who asked. So this could be wrong. So we will just check this afterward. Now, exercise 3. A random variable x can assume 0, 1, 2, 3, 4. So x can take any values from 0 until 4. A probability distribution is shown here. Find px is equal to 3 and px greater than 1. Okay, can you try? Before we can try, okay, can we find what is the value for this particular question mark here? How to find question mark here?
1 minus
find
all of the
One
Yes,
minus.
yes.
1 minus
1 minus all the probability values that you have. So that will be 0.1 plus 0.3 plus 0.3 plus 0.1. So what is the value here?
0.2.
Yes, 0.2. Now you know that this is 0.2. Then you can start calculating exactly 3. Now, what about exactly 3? Okay, exactly 3. What is the value? So it will be 0.2. 1 minus all the value that you have just now, it will just write down 0.2. Okay, what about px greater than 1? If you're talking about greater than 1, then we are talking about, is 1 included? No.
No.
No, so it would be
No.
beginning from 2, 3, and 4.
0.6.
Okay, so you have 0.3 plus 0.2 plus 0.1, or if you wish to write down, this will be px equal to 2 plus px is equal to 3 plus px equal to 4. So the disadvantage of learning out online, when you have the assessment, this particular understanding will not be asked to you, because what we need afterwards is your answer for this particular question. So you will get 0.6. Yeah. Okay, done for exercise 3. Now, what is the time now? Okay, we have almost half an hour. So let us finish the last part of our chapter 2. First half of chapter 2. Now, knowing that we have a discrete random variable, okay, so we can find the cumulative distribution for this particular discrete random variable x, denoted as function of x, capital letter here. Okay, now regardless of all the things that we have discussed just now, now we are talking about cumulative distribution function. What is about this cumulative distribution function that we need to know? First, the nomination or the notation for this particular cumulative distribution function is written as capital Fx. Okay, capital Fx. Now, this capital Fx is actually taking the probability values, probability distribution that we have seen just now, and we can find from summing all the function of that particular function in terms of, in this case, is t. The same as what we have in this case is actually t is taking the value of x. Okay, so originally you are talking about fx, and this x taking p-values, and these p-values can be less than or equal to this particular x. Let us see later. For a discrete random variable x, the fx satisfies the following, almost the same as what we have just now. Now, this one is actually the what we call this the summary of what we have done just now about this one and this one. Okay, and this is actually how to what we call simplify if you have these phrases in your question that you need to answer. So this actually can simplify your process. Okay, first we know that the function can take values from 0 until 1. This is the common understanding that we have knew already. And if x is equal to y, then fx is less than or equal to fy. So this one can be understood if I explain this. Okay. Now, okay. Oh my goodness, it happened again. Okay, let me check here first. Hold on, Okay. Now, let us answer this by looking at this explanation. If the range of a random variable x consists of the values, now this particular x, remember, are all the values that can be taken by our small x. Okay, and we know that this small x can be replaced into your function of x that we are talking about just now, the cumulative distribution function for this particular discrete random variable. Now, if let's say you wish to find, okay, let's say if I rewrite this again, let's say you wish to find fx where x is equal to, for example, 5, this can be obtained actually from I minus 1. So if let's say this particular values is I is equal to, let's say I is equal to 5. Okay, I is equal to 5, then x5 can be obtained by x5 minus fx4. Okay, if to be precise, my x would be small x. Okay, small x. So x, I'm looking for x5. So x5 minus x4. Okay, it's just the same of what we have done so far. But before, in this case, we need to sum each element that we are talking about. Now, we can simplify this by not taking all the element in your calculation. We simplify by deducting the terms involved only. Okay, so how we can apply this? Let's say, look at this particular example 4. Given the probability function 5 minus x divided by 10, for x equal to 1 until 4, find fx. Okay, so how do we answer this? Almost the same of what we have done just previously. So we have our x here, and then our x begin from 1, 2, 3, and 4. Okay, and we have our px equal to x, where x is equal to 1. So in this case, if x is equal to 1, so we have 4 over 10. X is equal to 2, we have 3 over 10. 3, we have 2 over 10. 4, we have 1 over 10. Add them all, we get 10 over 10. So this is a probability distribution Now we have our probability distribution. Now we need to find fx. So our fx here is the one that we wish to find. So x, I equal to 1, I equal to 2, I equal to 3, I equal to 4. Okay, so class in this case begin from fx equal to 1. How do we calculate? So in this case, if we wish to use this, in our case, this will be what? F1 will be what?
4/10.
Yes, 4/10. Okay, now for I is equal to 2, this will be what? This will take what? Fi, this will be 5, F2 will be, sorry, this will be F1 plus F2. Let me rewrite this first. F3, this will be F1 plus F2 because we are talking about cumulative class. F4 would be F1 plus F2 plus F3 plus F4. Okay, so F1 plus F2 for equal to 2. So this will be what? 3. What about 3? Sorry, 2 plus. This will be F1 plus F2. 4 plus 3, you get 7/10. For F3, adding F1, F2, and F3. 2 plus 3 plus 4, you get 9/10. And 4, you will get 10/10. So this is what it meant by Fx in your case class. Additional of one more row that representing the Fx. Okay, so this is your Fx. Any question class in this case?
Okay, Doctor. No question.
Yeah. Okay. So we haven't seen this yet. This one we didn't use yet. We are going to use afterwards. Okay, we are going to use afterwards. Now, this is what we call as Fx. Just now we are talking about probability distribution, and the probability distribution is representing by these two rows. And if you are talking about cumulative distribution function means that you accumulate one by one. So this is what it meant by accumulating one by one. So from F1, F1 plus 2, F1 plus F2 plus F3, and finally you will get 1 for your all summation of your probability. Now, next. From this particular, what we call cumulative probability distribution function, you can find the expected value, or we call it as the mean, okay, of your random variable x. Sometimes we call it as expected value of x. It's just the same. What is the definition of this mean of random variable x or expected value of x? Sometimes it will be written as this one, okay, mu is equal to mu of that particular x random variable x is equal to expected value of x. That will be the mean. This one is actually representing the mean. This one is the population mean. Okay, how to find the population mean? So this is the formula. I will multiply each of the function of x with the x involved. Which x? Which x? This one. This x, 1, right? And this particular fx. This one is our f1. Okay? Or fx1. This one is your fx2. Okay, so on and so on. So this is your how we can find the mean of this particular random variable. Multiply this with your fx. Multiply x with your fx. Continue until finish. What about finding the variance? Okay, the variance of x, okay, known as sigma squared or sigma squared of particular random variable x is obtained by ex minus mu, the mean squared. So this is the variance, okay? Or sometimes we call it as sigma squared, or to be specific, sigma x squared. Now the variance of x can be obtained by counting using this one, okay, for discrete random variable. And the condition for this variance x only exists if mu is equal to ex and ex squared both exist. Okay, so finally the way you calculate your variance of x is using this particular formula to be easy. So you are going to use this formula to calculate your variance of x and this one for mean of x. Okay, so these are the two formula that you need to use. Now the standard deviation is just because we have here just now sigma squared. Okay, taking out the sigma, the square to the other side, it will give you the square root. So that's why we have the square root of variance x will give you the standard deviation of your random variable x. Now, there will be few properties of expected value of x. Okay, what will be the properties? If you have a constant a and a constant b involved in your calculation, okay, expected value of a will always be the constant value. If you have the expected value of bx, okay, what is b? Any value. For example, expected value of 2x. It just simply 2 expected value of x, taking out the values out, you will get the expected value of x. What about expected value of ax plus b? So you can taken out one by one. So you will get ex plus eb is equal to b. So you will get this phrase. If you have two random variables, need to find the expected value, it will just simply the expected of value of the first variable plus the expected value of the second variable. Kind of dry explanation, right? Because it's just a theory of this particular properties. And for the variance, okay, variance for any constant, always 0, remember? Okay, variance for any random variable with coefficient in front, your coefficient taken out and you have to square the coefficient value and remain variant x as the other side of your variance x. If you have variance ax plus b, then as usual, a taken out, it will be a squared, variance x, variance b, we know it will be equal to 0. That's why here equal to 0. Okay, so these two properties are very important in order for you to calculate your equations. Let us look at the first example. Find the mean, variance, and standard deviation of the probability function fx equal to x over 10 for x equal to 1 until 4. So remember, you need to begin with the what we call calculation of what we have just now. Find the mean. How to find the mean? The mean can be calculated using this particular phrase. Expected value of x is the summation of x multiplied with the function of x. That's x specific. Okay, so how? So mean or expected value of x be careful of writing of how you can write your x, capital letter. So now we know that expected value of x is equal to summation of x multiplied with fx. Okay, where I is from any value to any value. So here we have from 1 until 4. So we have x multiplied with fx. Our x is 1 multiplied with x over 10. X for 1 is 1 over 10 plus 2, 2 over 10 plus 3, 3 over 10 plus 4, 4 over 10. So what is the value here, class? No need to set the cumulative distribution as what we have done in the table just now, because we need to answer the question right away for mean, variance, and standard deviation. So what is the answer here, class? Anybody?
Three.
It's 30 over 10, right? And then you get
Yes.
3, correct? Okay. Now you need to find the variance. Variance of x. Okay. So how to find the variance? The formula just now. The formula says the variance is expected of x squared minus expected of x squared. Okay. So now you have got your expected of x. You need to find expected value of, so you have expected value of x squared minus expected value of x squared. So you need to find expected value of x squared, right? So expected value of x squared is 1 squared 1 over 10 plus 2 squared 2 over 10 plus 3 squared 3 over 10 plus 4 squared 4 over 10. So what did you get here?
Uh, 10.
Okay, you get 100 over 10, you get 10, correct. So now we can finish our variance. So variance of x, okay, using this formula, so you get 10 minus expected value of x, that will be 3 squared. So you get what? 1, right?
Yes.
So standard deviation, that will be sigma is equal to square root of 1, you get 1. So that's how we calculate the mean and the standard, the variance and the standard deviation of this particular example. Now, let us look at this particular question in your exercise before we can finish our class. You have, I think if I'm not mistaken, you have 7 or 6 questions. 7 questions. Okay, this one is very simple. Okay, we are using the properties in order to find our solution. You are being given the expected value of x is equal to 7, expected value of y is -5, and you need to find the expected value of 4x minus 2y plus 6. Okay, so this one is very easy, straightforward, just to give you the feeling of how to solve this. So this will be 4x minus expected value of 2y plus expected value of 6. And then you can solve this, become 4ex minus 2ey plus 6. Expected value of 6 is equal to, that's constant value, right? So you can find the answer. What is the answer? The answer is 44. Okay, 44. So you get 4 multiplied by 7, you get 28 minus 2 minus 5 plus 6. So you get 44, right? So easy. Let's look at this one, second one. I think this one, okay, kind of interesting to solve. Can you try this, class? Find y. What is y here first? Y equal to what? I know the answer. How?
0.03.
Yes, how to find the 0.03? It will be 1 minus the whole probability value 0.02 plus 0.03 plus until 0.07. So you get 0.03. Okay, now you know that this one is 0.03. Find expected value of x and expected value of x squared. Can you try now, class? It's a bit tedious, because you need to use the calculation formula. So the expected value of x would be summing all the multiplication of the x value with the probability or the fx. So 1, 0.02 plus 2, 0.03 plus 4, 0.2 so you will get 496 here. Okay, so for x squared, you will get 1 squared 1, so 0.02 plus 2 squared 0.03 until 8 squared 0.03. Okay, you will get 0 point, is it 0 point? No. .34, right? So then using this, from B you can find your C. Variance of x would be EX squared minus EX, the whole thing squared. So you get 26.34 minus 4.96 squared. So you will get what? 1.7384. Okay, and if you find your sigma, this will be square root of 1.7384. You will get 1.3185. Okay? Any question here, class? Any question?
No, doctor.
Okay, clear, right? So this one, I think almost the same as the first question. Just apply the properties of these particular phrases and then apply using the values given to you and you can solve that. Question number 4, the table represent the number of cumulative distribution. CDs. CDs sold for a certain month and their probability distribution. So 80 CDs, 19 CDs, 100 CDs sold in a month. Okay, and then you got the probability value. Find value of A and B if the expected value is 104. So this one, if I'm not mistaken, you will get a kind of simultaneous equation. Simultaneous equation of A and B. So you can try, yeah? So how to find A? By applying the expected value of X given as 104. So here, you can try it. So you can apply expected value of X is what? 80 times A plus 90 times 0.2 plus 100 multiply with B plus 110 multiply with 0.3 plus 120 multiply with 0.1 plus 130 0.1, okay, is equal to what? 104. 104. So you can solve this. You have A and B. The rest are number. All the number bring to the right hand side, and then you can get the other answer for. So this will be your first equation. How to find your second equation? Okay, class, I think you can try. Go back and try how to find your other equation for your simultaneous equation. Okay, so you have question 5, 6 and 7. You can try on your own, and if let's say you have any problem later on in the earlier class, before we begin with the continuous random variable, we will discuss the first question that I mentioned just now, the camera that failed, okay, and then the rest of the questions. Okay, any question, class, so far? So now this one, you can get the first equation is using the given value. What will be the second equation from, class? To solve for this simultaneous equation, you should have two equations to be solved. Now you got your first equation. What will be the second equation that you need to come up with? Can someone?
The total probability will be 1.
Yes, the total probability can be 1. So you get 80A plus 90 0.2 plus 100B plus until 130 0.1 is equal to 1. So this one is your second equation. Simplify until you get A here plus B here, and then you got the coefficient is equal to 100 and something. Is something here because you need to deduct with this. So this is your first equation, and your second equation is 80A plus this one also is 100B, sorry. 100B is equal to something value. This one is also 80. This one is also 80, 100. No. This one is A only. I messed up already. Yeah? So this one, nobody correct me. Do you understand or not what I'm talking? Your friend said just now, the addition of the probability. So it will be A plus 0.2 plus B plus 0.3 plus 0.1 plus 0.1 is equal to 1. So you get A plus B over here equal to 1 minus the rest of the values. Okay, so you get second equation. So you can solve this equation. So this one is 100B equal to something. So solve this equation and you can find A and B. Okay, class? So I think that's all for today. Thank you very much. I owe you an explanation for this one. I'm trying to figure out the easiest way to explain to you this one. Okay? In the next class, I will just explain this. Okay? Let me stop.